We have some solid understanding on some of the basics of Hibernate. Now it's time to take a look at a very simple CRUD application where we perform the basic database operations like create, read, update, and delete. In a typical real-world web application, this is how it works. You'll have some front-end technologies like HTML or JSP on which the end user will interact, and the request will get forwarded to a controller logic, and something like servlet will take the request and forward that request to the next layer, which will be services layer, where the actual business logic will take place. So here you may use enterprise Java beans, etc. But this business layer is actually going to instantiate so-called a data access object. So data access object will have set of behaviors or methods, and each method will have a certain logic to interact with the database. In our simple CRUD application, we're not really concerned about all these layers on top, but instead we're just simply going to replace the business logic with the main method, which will reside in a separate class, and this class will interact with the DAO class, where we'll have all the list of methods that perform the CRUD operations to talk to the database. Now I can walk you through how this is achieved, but I want you to give it a try before you move on with my next video. But let me just give you a glimpse of what we're trying to do. Let's go to Eclipse. Okay, here is our DAO class, and here I've introduced few methods. The first of which is to load the session factory, and then we have a method to create a list of employees. I'm just simply going to use a for loop to populate the data in our table using Hibernate, of course. And then we have this read method, which when called would return a list of all the employees residing in the table. And we have the update method, and we're going to pass the identifier as a parameter. And based on the ID that we sent, its respective entry will get updated in the database. Similarly, we have delete record, and we send an identifier as an argument. And based on the identifier, we would delete an employee from the table. And finally, we got delete all method, which when called will delete all the entries in the table. And we have close session factory to close on the session factory. Pretty straightforward. And its corresponding main method from where we trigger everything, and we call all those methods. In our employee.java, which is a persistent class, I have now made this ID part of this constructor. That's because in real-world applications, the ID will be sent automatically by the view layer. But since our application is not a full-fledged MVC application, we have to explicitly provide the identifier from our main class. And that's why I had to add this in here. You'll see why when I demonstrate the example. Also, I have overridden this method toString so that when you're trying to display objects of this class, you would see a meaningful string rather than some random set of characters and integers. And in our config file, I've disabled these two properties because now we're performing quite a bit of transactions, and this is going to display all the SQL statements. I don't want that to happen. That will dilute the actual messages. So I have disabled this for the time being, and I have set this property to update. Actually, I have intentionally left one issue with our program, and when I talk about it, I'll also talk about this particular field. And in our pom.xml, I have actually added this library, log4j, which is a framework. Now this is nothing to get scared if you're not aware of log4j. We're just using this just to disable some of the unnecessary messages that gets displayed on the console. We're still using the good old system.out.println everywhere. We're not using that framework. I've used this just to address that particular problem, because when you get to see the output, we don't want to see all the Hibernate logs in here. We want to see whatever we're trying to display. So even if you don't have this, that's fine. It's just for our convenience I've done that. And we have this file, log4j, which corresponds to this framework, log4j.properties, that resides under the resources directory. And I have set this to off. This is what will disable all the logging to get printed on the standard output. So that's about it. Try to write the program on your own. It doesn't necessarily have to be the perfect code, but just give it a try. I'm going to walk you through all these in my next video anyway. So see you soon. Okay, first of all, let us explore what's happening in this data access class. The first method is to load the session factory, and the code inside it is pretty straightforward, and I'm sure that you're already aware of this. I've picked this code from our previous examples, and we're actually going to call this method from some of the other methods we have in the same class. Let's take a look at how we perform the create operation. So as usual, we have initiated a transaction using the session object, and we are committing the transaction, and between these two we are performing the insert operation. Well, we know this instruction already, but the only thing changes in here is that I have added this for loop to add 10 entries, as simple as that. And I'm trying to save each and every object while we loop through. And rest of the code is just as our previous example, nothing different. We have catch block to catch the exceptions, and in case if there is any exception, then we are trying to roll back the transaction, and we got the finally block to close the session. And we have read method to read all the entries from the database. The code in here is almost similar to what we have seen in create method, but the difference is this part. So here's something new. We're trying to use Hibernate query language in this way to read all the entries from the database. So I do session.createQuery, and I'll pass in some string, and this has to be Hibernate query language. We're going to talk about Hibernate query language in future videos, but for now, this is a statement that you need to use to read the data from the employee table. Also, do take a note that you should not give the actual table name in here. As we've already talked, this is supposed to be the class name, the persistent class name. So this is going to return list of employees in the table, and the beauty of this is we're not really typecasting, or we're not taking care of converting this into our employee object. It's all done by Hibernate automatically, and so we're able to directly assign all those entries into the list of employees. So that's the beauty of Hibernate. And in our update employee method, I'm passing in one argument, which will be the ID of the employee of whom I want to make some updates, and all the code will remain same, and only part that changes is this. So we're trying to get the employee using this statement session.get, and then I would pass in these two arguments, and I'm trying to typecast this to employee object. Well, I believe we don't have to do this. I can just get rid of this. And what comes next is we're trying to update that particular object by calling the Pojo method, and I'm sending the new updated value. And finally, we have the delete record method, and we're passing the identifier, the employee that we want to delete. And as usual, everything remains same except this part. So this time I'm trying to do session.load and passing the same arguments what we had passed in here while updating. And again here we don't have to really typecast as such. And I'm calling session.delete, passing that object to delete. Well, you may be asking, what is the difference between session.get and session.load? Well, in terms of functionality, it doesn't really matter much, but session.load offers lazy loading. We'll talk about lazy loading in Hibernate in coming videos for sure, but roughly speaking, load will not load the actual object, but it would rather load a sample object which doesn't actually represent the existing object, and then when you're trying to do something, then the actual load will happen. That's when the actual object will get picked up. So only when we do something with it will the Hibernate get the actual entry or the object from the database. If the object is not present, then Hibernate will throw an exception. But coming to get, If the object is not present, then we just simply get a null value. So ideally, before we perform this, we should check to see if the object is null or not. Only then we will update. Otherwise, obviously, we'll get null pointer exception. So that's the basic difference, but we're going to talk about the lazy loading in coming videos for sure. And then we have this method delete all, which will delete all the entries in the table. And here is again the Hibernate query language to do the same. And finally, we have a method that we're going to call to close the session factory. Alright, in our next video, we're going to take a look at the main logic, and we'll also take a look at how our application runs. See you soon. Okay, let's take a look at what's happening in our main method. All the code in here is pretty easy to understand. I'm not sure if I need to walk you through, but I'm just doing it anyway. So what we're essentially doing is to call all those methods in the DAO class one by one. So we're trying to add entries into the table by calling this create method, and then we're trying to read whatever has been added, and we're just looping through all the entries to display them. And this is the reason why I had to override the toString method, so that when you're trying to display these objects, they would be displayed in human readable manner. And similarly, we're trying to update a record by passing the identifier. In this case, I'm trying to update the employee with ID 5. And after I update, I'm again trying to display all the list of employees. And similarly, I'm trying to delete an employee with ID 2. Again, I'm trying to display everything. And finally, I'm deleting all the records in the table. Of course, we're closing the session factory in the end. So let's take a look at how things will go. Let's run the program. Creating the employee records. So after employee records are created, we're trying to read the same, and here are the list of employees. And then we're trying to update the employee record with ID 5. If you take a look at the employee with ID 5, his name is now updated with something else. And similarly, we're trying to delete the record with ID 2, so you don't find employee with ID 2 in here in this list. Deleted all the records, closed on the session factory. But do take a note, although we closed on the session factory, our process is still running. Can you guess why? This is the issue that I was talking. Let's stop this. Let's go to our DAO class. So here is where we have the issue. Can you make a guess on what's going wrong? We have a serious issue, something to do with performance. Pause the video and try to fix the problem. If you're not successful, just continue watching. But don't give up on trying though. So here is where the fix needs to go. Every time you're calling this method from all these methods, we're reinitiating or recreating a session factory. That is a very expensive thing to do. You have to try to create only one session factory for application, and we want that session factory to stay alive as long as the application is running. So in here we can just quickly check to see if session factory not equals null, then we just simply return it. Return session factory. As simple as that. So if the session object is already existing, then we'll just simply return it. Otherwise, we'll go ahead and create one. Now let's try to run the program and see if things will go well. Sure enough, after closing the session factory, our process is also done. I'm going to make this project available for you to download, so do give it a try. Otherwise, just import the project and use mine. Alright, see you soon.